welcome to HANSA.newscast. I'm Janne Silden, and today I'm joined by Patrick Ryan, Chief Technology Officer at ABS. We are going to take a closer look at nuclear power propulsion, a field that has moved quickly from theory to active development in commercial shipping. I'm glad to explore this topic with you, Patrick, given ABS' role in several key regulatory and technical initiatives. Welcome.
Thank you, Janne. I'm really excited to be here. It's a favorite topic of mine.
I'm really looking forward to learn more about this hot topic. Let's just jump straight into it. Mm-hmm. Nuclear has re-entered the mainstream conversation for commercial shipping. What changed?
What changed? Good question. So, my background, Janne, before I joined ABS was in nuclear ship design in the United States for over 20 years. So from my perspective, it's always been around. It's been around for a long time. And when you look at the history of it, nuclear propulsion and shipbuilding has been around since the late 1950s, early 1960s. It's the commercial element that really has changed. And I think a lot of that was really driven by the energy transition, the decarbonization discussions that have been dominating the industry for the past several years, and some of the technical challenges with some of the alternative fuels, all of which have some level of risk. And I think when the topic of nuclear comes up, there's a fair amount of skepticism. But really what has changed is the technology as well. Okay, so the discussion has changed and the tech has changed. What's happened, I think, obviously in the United States, that's where I see things the clearest, so I'll use that as an example. But it appears in France and in other Western countries as well. But as large cities use nuclear energy, yes, typically, in the U.S. at least, the smaller towns still have the coal-fired power plants that there's really a laser focus on replacing. And so some of the technology that you would use at a smaller scale has really evolved. So this is what we would call an SMR, or a small modular reactor, yes, that doesn't have the big gigawatt level of power output that a typical nuclear plant has. And kind of as that technology has evolved for smaller markets terrestrially in the United States, the shipping industry took a look at it and says, 50 megawatts is about perfect for a big ship. And so there seemed to be a lot of synergy with the scale and the size of the technologies that kind of moved forward. So those are kind of the two of the big things, but certainly we could talk about that a little bit more as we go through the discussion today.
Yeah. So ABS designs rules for technologies that don't yet exist in commercial operation. How do you do that?
So for nuclear, we do. And so we put out our first set of rules over a year ago in October of 2024. And we're very proud of that. They're focused on power barges first. But how do you develop a set of rules for technology that's still kind of evolving? Well, first thing to kind of really understand is class societies are not going to license the reactors themselves. So the way we approach it is the reactor will have some kind of a licensing entity. Typically that is a governmental entity. In the United States, it's an entity called the Nuclear Regulatory Commission. So the NRC issues the license, and they have their own rules for the reactor itself. But the NRC doesn't do anything relative to a ship or a vessel or a power barge. That's where class comes in. And so there's an interface between the two. And so as we develop our rules, it's really to apply to the vessel side of things. How does the vessel need to handle firefighting? How does the vessel need to handle emergency power? How does the vessel need to handle the fact that you've got this very special power plant installed aboard? That, I don't want to call it a black box, but there are elements of that class won't touch, okay? That the licensing entity touches. Now for us to really kind of understand how to build that interface, we do a series of projects. We typically do what we call joint development projects, which is typically with a shipyard or a design firm where they're interested in the technology topic, as are we. And we collaborate on that together, and then we use that as the basis for our rules. In the case of nuclear, we ended up sponsoring a few projects ourselves because there was so much interest and people wanted to learn about it. We wanted to be able to build some documents that we could publish, because usually joint development projects with a client of ABS are held close and they're not made public. So there are a series of documents that can be downloaded from the ABS website that show some of those designs and what we use them for to really kind of push the envelope on the rules. And then the rules ultimately is the product of those types of projects.
Yeah. So from a technology and safety standpoint, what defines modern marine nuclear concepts?
Well, typically, I think kind of the biggest way I would say what defines them is usually the fact that they're small modular reactors, as I mentioned previously, which are kind of leveraging what's going on terrestrially for land-based small designs. The modularity is something, of course, that makes them, in theory, mass-producible. Oftentimes when I'm on stage or people ask me what's the biggest impediment to all this, it's the manufacturing, in my opinion. A very close friend from a firm that produces naval reactors for the United States Navy, I asked him how many reactors did he build in his best year, and the answer was 3. So you're not going to move the needle very far if you're only producing 3. How are you going to produce them at scale?
Yes.
And so getting to a place where you can build them modularly at a shipyard is a place that I think the industry will need to go. And then, of course, the other thing that will define the reactors is the technology type. It's usually defined by what cools the reactor fuel. So often you'll hear about molten salt. Molten salt is
Yes.
really kind of captured the imagination first. That's using a salt in a liquid form. It's usually around 800 degrees Celsius or thereabouts as a coolant to the reaction that is used to then produce steam to produce electricity. But you will also hear about molten lead reactors. You'll hear the very classic is pressurized water reactors.
Yes.
Or you can hear about heat pipe reactors or high temperature gas reactors. The descriptor in all of these different reactor types is actually the coolant used to control the reaction. So that's really, I think, what typically defines, to use the term, what the reactor is or is about. And then it comes down to how do you convert that heat into mechanical power or electrical power to use for your intended purpose, whether that's ship propulsion or in the interest of power barges, or can I use this to produce alternative fuels, ammonia or hydrogen is using the electricity as the means by which to convert some feedstock, perhaps seawater, into hydrogen and then into either liquid hydrogen for a fuel cell or ammonia for alternative fuels.
Yeah. So where does nuclear actually make sense and where not?
Well, I think it does seem to make sense in power barges. I think when we hear a lot about some of the first projects, and you go and you'll Google what nuclear projects maritime, you'll see a lot of power barge projects, whether out of Korea, whether out of Northern Europe. One of the earlier projects was done by a company called Seaborg that is interested in the power barge concept. And there's a lot of, I think, goodness there. When the movement kind of started, we didn't really have AI in the conversation. But now that we do, everyone is thinking about not only offshore power barges, but offshore data centers, where it's all self-contained and really kind of the driver is the huge energy consumption that AI has brought and kind of when you look at some of the investors in the United States, it's all the big tech firms. There's a lot of interest in not just terrestrial, but marine also. So power barges will be, I think, what we'll see first. And then the other, kind of interesting category that I think will follow quickly will be some type of support for energy production, not meaning electricity for the grid from the plant, but production of alternative fuels, whether that's a reactor to support an offshore hydrocarbon facility, or whether that's to actually produce, as I mentioned in the prior question, hydrogen or ammonia. And then I think finally we'll eventually start to see it in ships. And I think the big challenge for shipping will be construction of the reactor plant. But there are certain vessels that do seem to make sense. Container ships would be probably top of my personal list because the impact to the naval architecture elements. The reactor is still fairly heavy and still needs shielding, and so it tends to be arranged amidships to kind of reduce the moments on the vessel, the structural moments on the vessel, and keep the weight down, structural weight down. And that tends to impact cargo. And so when we think about something like a gas carrier, that makes the arrangements quite difficult, whereas a container ship is a little easier. And so I think large container ships that are moving from supported ports to supported ports will be probably the first types of vessel that we'll see. And I guess that's, not to go too long on answering your question, but that's another factor, is the port support for the ship as well.
Yeah.
Whether it's, unloading the energy while the ship is docked, or just the regulatory or statutory requirements that the port will have will need to be pretty special. And so dedicated trading routes will be an important part of the future of nuclear shipping, I think.
Yeah, it just comes to my mind, how about charging batteries?
Yeah, 100%. So typically a nuclear vessel will have a battery backup, and we will have a requirement for backup power from a class perspective anyway. You could use a diesel generator or something like that, or you can have a battery backup power. But, could you use a nuclear reactor to charge and support an electrified port?
Yes.
And not just the port operations itself, but the harbor craft and the tugs and the small vessels that support it. That's a great application for electric power. So those vessels wouldn't be necessarily nuclear, but they would be supported by a port-supplied nuclear floating power barge to really kind of electrify everything that's going on in the ports. And ports are interesting because they tend to be close to population centers, where the actual exhaust is a factor for folks. And, balancing the needs of, whether society doesn't want emissions close to where people live, but they may or may not want nuclear power either. Putting it on a floating power barge allows you to move it away from shore.
Yep.
And bring it back in. And I think that standoff distance will really kind of help in a few areas. Permitting and licensing, it helps. But when you think about the most recent nuclear incident in Japan, which was the Fukushima incident a couple of decades ago, it was a seismic issue, and when you float a reactor, the water column tends to decouple seismic activity from the reactor, so it's an added safety benefit to float a reactor as well.
Yeah. What is the best realistic timeline, and what will actually determine it?
So that's a really good question and a really popular one. Everybody wants to know when, from whether you're an investor or whether you're just an enthusiast in the industry. My typical answer is probably 2035 we'll see the first power barge in service. I think what will impact that will be the role of governments. I think if a government stepped in and said, no, we want something faster, it could be done faster because the technology is largely there, but the permitting and the regulatory side still needs a long time to develop. If you just let kind of market economies develop it on their own, then it's going to be financially driven, and it will come down to how can we as a society produce reactors at scale that can be economical, and at scale I don't mean the size of the reactor, I mean the quantity of the reactors, and that will probably lead us to a floating power barge scenario, and probably the kind of time frame that I just mentioned, probably about 10 years from now.
Yeah. A final question, Patrick. You mentioned that you worked earlier also on nuclear technology. What do you find most interesting about working on nuclear propulsion at this stage of your career?
Well, I think the technology has come a long way. As kind of a career technologist, that's always interesting to me, and I like, to see kind of the evolution from pressurized water and what we call Generation 3 reactors to the new technology in Gen 4, which reduces pressure and kind of reduces kind of the planning zone that is necessary. But what I think is interesting to me is, when you step back and you kind of look at really big picture, like what are my children going to be dealing with? My daughter's, of course, super fascinated by this topic, and she wanted to go into nuclear engineering. She chose chemical engineering, will be studying nuclear, and the kind of the societal change is like super interesting to me as well. Like when I was, a child and I grew up during the Cold War, there was a completely different attitude than I see young people today. Young people today care about the environment, and they think, an emission-free power source is the right solution, and something that is energy dense and has, long legs and doesn't have the intermittency that other green solutions might have. I think that it's attractive to young folks, and so you see kind of that tide of opinion swinging with generation and with that change. And so all of that's really interesting to me, and I think as you zoom out and you look at kind of the societal shift, I think nuclear makes a ton of sense.
Yeah.
Makes a ton of sense for humanity in a big picture going forward. And if you fast forward to 100 or 200 years from now, when we're all gone, what will international shipping look like? Because humans will still need to move goods and services and products over the seas. I think you'll see a lot of nuclear energy, and we're just at the beginning of it today, and that couldn't be more exciting to me.
Yeah. Thanks a lot, Patrick, for sharing your insights and also your personal interest and views on nuclear.
Thank you, Jana. It was a great conversation. I had a lot of fun with it.
Thanks for listening to HANSA.newscast. Subscribe now for more insights and stories from the world of shipping. And feel free to visit HANSA.news and sign up for the HANSA newsletter to stay up to date. And hey, see you at the next episode. Bye.